Hi there. Here's my solution to the investigative task, the number 6 free response, where you are essentially constructing a one-sided confidence interval. The first part of the question is a great review question. You are simply calculating a one sample t interval, so this is not meant to be anything overly complicated. Something to think about though, in terms of the rubric, in order to get credit, in order to get essentially correct on this part of the question, you have to do 4 things. You have to make sure you check your conditions. So we have a random sample, we have our independence condition, and we have our normality condition. So it's important that you check your conditions. It's important that you identify the procedure and calculate the interval. So you can calculate it on the calculator, that's fine, but you're doing a one sample t interval in this case, and then you need to make sure that you interpret it in context. That's very important. So just to review how to do this on the calculator, so again, this is completely review. If you go to stats and tests, this is an interval. So we're going to go down to the option t interval. There it is. So we're going to enter the statistics. That's what we're given. We don't have a data list that we can enter. So the mean that's given to us here in the original statement of the problem, the mean is 24 milligrams per deciliter in terms of cholesterol reduction. The standard deviation is 15 milligrams per deciliter. And the sample size here is 50. And in this case, we want a 95% confidence interval. So change your confidence level to 0.95, and there you go. The 19.74 to the 28.26, that's where it comes from on my solution. So a partially correct answer will only do 2 or 3 of those steps. An incorrect answer would be at most 1 step. So next part of the question then, in part B, an essentially correct answer here will do 2 things. It will explain the confidence interval is 2-sided and the test is 1-sided. So notice 20 is in the confidence interval, and notice that I've even rewritten the interpretation in terms of the 2-sided test. A confidence interval corresponds to a 2-sided test, but the test is 1-sided. So first of all, you have to make that statement. But then in addition to that, you have to connect that to the p-value and to the confidence level. So notice for the 1-sided test, I'm talking about the p-value. However, if that test had been 2-sided, that p-value would get doubled, and you would not be able to reject the null hypothesis, and that would be consistent with the confidence interval. So a complete answer here, an essentially correct answer, needs 2 components. You need to be talking about how the confidence interval is 1-sided, but the test that we're talking, a confidence interval is 2-sided. It corresponds to a 2-sided test, but the test was 1-sided. And in the context of the question, then you have to explain what's going on in terms of the p-values. You have to connect the difference between the 1 and the 2-sided test to the difference in terms of the p-values. So, in part C of the question, an essentially correct answer gives the correct value for t star, the correct critical value, and also shows the work for calculating the boundary for the 1-sided confidence interval. So notice I said that t star that we're looking at should be at the 95th percentile. So the entire rejection region is above the critical value. So I indicated my degrees of freedom and I indicated my value. So you can use your inverse T command or inverse T program in order to do that. But then it's important, it may be simple, but you need to take that score, that critical value, and incorporate it with the work. Show where that 20.44 is coming from. If you only do one of those 2 parts, it's a partially correct answer, otherwise it's incorrect. And then lastly, in part D of the question, there are 2 things for an essentially correct answer. You have to justify whether or not the conclusion has changed, and indeed, yes, the conclusion has changed, but your justification should also be supported by some type of a comparison. So notice here, I'm strictly comparing that value of 20 that the regulatory agency is interested in, I'm noting that that 20 is outside of this one-sided confidence interval. So in fact, we now have evidence that that mean reduction is indeed above 20. The entire region above our one-sided confidence interval's boundary of 20.44, I'm 95% confident that the true mean reduction in cholesterol is greater than that 22.44. Notice I have a little bit of a typo there. That should be not 22.44, that should be 20.44. I will correct that on my Moodle page. So notice the value of 20 that we were interested in is outside of that boundary. It is below that boundary, and that's why we have confidence here. That's why our regulatory agency's decision has changed. So you can't just say, yes, the decision has changed. You have to link that decision regarding the 20. You have to make a comparison between the 20 and your new one-sided confidence interval. That linkage is important in the context of the question. Hope this has been helpful.